Ooh, all right. Hello, everyone, and welcome back to the ASP.NET Core Community Stand-Up, where we discuss the latest updates and developments for web development with .NET. I'm Daniel Roth. I'm the product manager for ASP.NET Core and Blazor on the .NET team. And today I'm here with Javier Calvarro Nelson, principal software engineer on the Blazor team. Javier, you want to say hello?
Hello, everyone.
Cool, great. It's great to have you here, Javier. Today we're going to be talking about some Blazor stuff. I know usually we focus on Blazor on our Blazor community stand-ups, which are the second Tuesdays of every month. We try to always talk about Blazor on those stand-ups. But Blazor is part of ASP.NET Core, and so today we're gonna we have so many Blazor features, I guess, to cover. We decided to use the stand-up to talk about some Blazor stuff as well. The topic for today is, I should get the banner going, is we're going to be talking about Blazor metrics and tracing in .NET 10. These are features that will help developers gain better insights into the performance and behavior of their Blazor applications, making it easier to identify and resolve issues. All right, so these are new features in .NET 10. We showed some of this at Build. If you attended the recent Microsoft Build conference, we showed some of the new Blazor metrics and other ASP.NET Core metrics as well. But we've been making more progress on adding new metrics for Blazor and also adding improved tracing support. So the things we're going to show today are actually based on .NET 10 Preview 5, which is the next preview update of .NET 10 that will be coming out shortly, like later this month, like in a week or so. So be looking for those bits to come soon. If you have .NET 10 installed today, you'll probably have .NET 10 Preview 4. So it might look a little different than what you're seeing in the demos that I'll show today. But soon, in about a week, you'll have these bits as well. And this is a work in progress. Like we're working on, exactly how we want these metrics to behave, which ones we feel like would be best to have there, how we want the traces to show up. So we're really using this as an opportunity to get your feedback on how to make the Blazor diagnostic experience as good as possible. All right, sound good? That's the plan. Let me go ahead and bring my screen back up. And let's go ahead and take a look at the new metrics. So what I'm going to do here, I have Visual Studio. This is the latest Visual Studio preview, which you should definitely get if you don't have it, because it's got all sorts of new, really cool like AI and Copilot features that are coming. But what I'm going to do is I'm going to go ahead and create a new Blazor web application. And in order to see the new metrics and tracing with this application, let's call this Blazor metrics. In order to see those new diagnostics, I'm actually going to use .NET Aspire. So I'm going to set up .NET Aspire with this Blazor web app. So let's go ahead and create that. We'll just leave all the defaults. So .NET 10 Preview, Server. Like I said, I have .NET 10 Preview 5 installed. If you do this today, you'll be seeing the metrics with .NET 10 Preview 4. But wait a week and you'll see all the other new goodies as well. And we'll go ahead and create that. And then I'm actually going to deliberately add Aspire to this project kind of after the fact. Like, I've got an existing app and I want to add Aspire to my Blazor app or my existing ASP.NET Core app, in part because I want to show how easy it is to really do that. Now, if you're going to add .NET Aspire to your .NET 10 projects, there is a little gotcha that you need to know about, which is .NET Aspire is currently, I think, version 9.3. I think is the latest release that they've put out. I think that came out at Build. They don't officially support .NET 10 yet. Now, .NET is obviously highly backwards compatible, so you can generally use stuff that was built for .NET 9 with .NET 10, but officially they don't support .NET 10 yet. So the tooling will actually block me. Like if I try to go into my Blazor app and say, let's add some .NET Aspire orchestrator support, that's the gesture we want to use. And of course, it disappears after I zoom out. But let's do add .NET Aspire orchestrator support. If I try to do this with my .NET 10 project, I get this error saying, hey, you don't have the .NET Aspire templates for this particular .NET version, because my Blazor app currently is, of course, targeting .NET 10, which is the new preview version of .NET. So in order to work around that, I'm going to do a little hack here. I'm just going to switch this to .NET 9 temporarily so that the tooling will let me add Aspire, and then I'll switch it back. And it actually does work just fine. It's just that it's not officially supported yet. So let's go ahead and add .NET Aspire orchestrator support. And yeah, we'll use the latest version of Aspire, which is 9.3. This will be our project name prefix. And then it will add also the two additional Aspire projects, which are the app host project. That's the thing that orchestrates and models your entire application. Here I only have one app project. I have my Blazor app, but if I had a Blazor app and API projects and gRPC services and so on, you can model all of that using this app host project and then get everything up and running at once during development and get a really great development experience. And then there's also this service defaults project, which is just a bunch of like convenient extension methods that will wire up all sorts of cloud-ready features in your ASP.NET Core apps, like open telemetry and health checks, things that are there and supported in ASP.NET Core, but it takes a little work to get wired up. Aspire makes that really easy to do by adding this service defaults project that you can use throughout your app. Okay, so we'll go ahead and do that. That will add Aspire. And then once that's done, we will go ahead and just flip my Blazor app back to 10 because I want to show the .NET 10 features. All right, and not 109. We're not there yet. All right, there we go. Okay, and then I should be able to run this now. And this will, you notice that the app host project is the startup project because that's what's now going to orchestrate and handle running all the different parts of my app. In this case, I only have one, but if I had multiple, it would start up all the separate processes. All right, and that should bring us to the .NET Aspire dashboard. Once it gets running, there's the apps going, and then we should see the great Aspire dashboard, which gives us a nice single place to view all of our telemetry, like our logs, our metrics, our traces, see all the various parts of our app, and follow the flow as the app executes. All right. Oh, just popped up here on my other screen. All right, there it goes. Okay, so here's the Aspire dashboard, which, by the way, is also built with Blazor. Everything you're seeing here is being rendered using Blazor components. We can see our Blazor metrics app, which is our single Blazor web app in this solution, and then I can click on one of the URLs to actually navigate to the app, and then we can click on the counter and so forth. So it's working. All right, so we've just Aspire-fied our Blazor web app. Super easy to do using the available Visual Studio tooling. Now, if you have a more involved application, like you've been working on a production app for a while, you might have a whole bunch more going on in your app, and it might involve a little bit more work than what you just saw here. But it's reasonably straightforward to add Aspire to existing ASP.NET Core apps. You don't have to really change like how you do things. You can if you have an existing deployment model, you can continue to use that. If you have existing infrastructure, Aspire adds to it. It doesn't necessarily need to replace it. But a really cool thing that just happened recently. Let me bring this up. Yeah, this. The Aspire team this past Friday held this Aspire Fridays event, like Aspire Fridays, where what they did is they tried adding .NET Aspire to a more real world ASP.NET Core app. In this case, the app that they used was actually Bitwarden's server repository. If I scroll down here, so Bitwarden, if you're not familiar with it, Bitwarden is an open source like password manager, secrets manager, passkey handling system, and it's all built with .NET. So if you're Bitwarden has not sponsored this this live stream, but if you're looking for a good password manager, Bitwarden is a great one to use, and it's based off of the .NET technologies. And their server repo is all ASP.NET Core code and implementation, all implemented in .NET. So what the Aspire team did is they took that project and they said, let's see if we can Aspirify Bitwarden on a Friday afternoon. David Fowler and Damian Edwards and Maddie and Glenn were all there together on the live stream for a couple hours, and they got it done. They were able to do it. So on a Friday afternoon, you can get your ASP.NET Core app Aspirified, which was pretty fun to watch. I think it's a bit of a it's 3-hour stream, but I think they're working on sort of a trimmed down version if you're interested in sort of getting the highlights. But pretty interesting to watch if you want to see the details of what it takes to add Aspire to a real world application. All right, so let's see now some new metrics. Okay, now before we can see the new metrics, like if I go to the metrics tab in the dashboard and we look at what's here, the new metrics actually aren't showing up yet. Like if I look at the list, I'm not seeing anything for my Blazor metrics app related to like ASP.NET Core components, and that's because we haven't actually added the meters for the new metrics yet to like the extension methods that like add the default set of metrics for ASP.NET Core. So we have to do that manually. So let's go ahead and set those up. So I'm gonna go back to my app, and in the server defaults project, I'm gonna open up the extensions C# file, and then let's go to the configure open telemetry method. Okay, so in here, give myself a little bit more space. This is where Aspire is setting up OpenTelemetry, which is a open set of open standards for gathering things like metrics and traces from applications for setting up observability. And here you can see where they're setting up which metrics do we want to actually collect for this app. And right now it's calling this sort of default add aspnetcore instrumentation method. That doesn't include the Blazor metrics yet. So let's go ahead and add the new Blazor ones. The ones you'll need to add are these. Let me grab them here. So these three are the new ones. So we've got aspnetcore components, of course. That's the default Blazor namespace. And then we got aspnetcore components server circuits, which adds some metrics related to like Blazor server apps and the number of active and connected circuits that you have. And then this last one, components lifecycle, is some lower level metrics related to like component rendering and component lifecycle. So you can try and track down if you have a misbehaving component that maybe isn't performing very well to figure out what's going on there. Okay, so let's go ahead and add that. And I think we will want to stop and restart the app just to, where did my debug button just disappear off to?
It disappeared.
Yeah, I know. The screen resolution is too low. It's probably one of these, right? It's probably like over here.
Debug.
There it is.
Go to the debug menu.
Yeah, so let's
I think he stopped the he stopped the presentation. Let's give him a minute so that he rejoins. Things happens. Well, I was supposed to be here to help him like talk through this, so maybe I can fill in some of the details while Dan rejoins, because I don't even manage the presentation. He's the one doing it normally. So yeah, the idea with the metrics that we've been adding for Blazor is to somewhat give you an overview of what's going on in your app, especially on Blazor server apps. When yes, maybe, especially when you, for example, have circuits and you want to know things like how many circuits I have connected, how many circuits I have disconnected. We're also going to give you some information about, for example, what components are rendering and what time is it taking on average for them to render and so on. So if you, for example, see that your app is being slow or things like that, you get a chance to look at the metrics and potentially see what component might be having problems. Maybe you have a component that is issuing queries to the database and is overloading it, and that shows up as failures or shows up as queries that at some point take a long time. So yeah, then what other metrics do we have? I don't want to spoil the presentation for him, folks, but I also don't want to be sitting in silence for like 10 minutes. Let me check real quick to see if at least he's around, because I literally don't know what happened to him.
Hello again.
He's back. Okay, Dan, I've spoiled the entire presentation.
What just happened?
I don't know what happened, but I told them everything about metrics while you were away.
I wonder if when I hit did it happen right when I asked Visual Studio to restart the app?
I don't fully, because I know what happened. it closed StreamYard because Visual Studio closed all the browsers.
Well, I think it might have done that. Yeah. So I won't press that button again.
So
Okay.
wait a second, because we're gonna have this instance again, because that happened to me a couple streams back.
Wow.
Uh,
Okay. Yeah. Usually I don't remove the bug.
select another browser to run the debugging, because if not, whenever you like restart, it's gonna kill the browser again.
I thought I had. Maybe I don't know. Did I have the StreamYard tab? Maybe whatever. Anyway, I don't know. I think you probably didn't even see the navigation metrics, right? So let me go back. So what I did is I got the app back running again. Sorry, folks. And so I browsed around to the homepage and to the counter page and back. And so the first metric I wanted to look at was this.
You're not sharing the screen, Dan. Sorry.
What?
Take a minute, settle down, get everything right, and people will wait for like 30 seconds. If they waited for me like for 5 minutes talking into the void, they will wait for you.
We're back. We're back. Okay, so I assume everyone can see now. Let's see how many
Yes,
comments. Okay,
we can see
great.
now.
Let's look at the new metrics, folks. All right, so first metric we're going to look at is the navigation metric. All right, and so as you can see, I've done this is saying I've done 3 navigations so far. Like I started on the home page and then navigated to the counter page and then navigated back. So this is basically just an incrementing counter of how many navigations have happened. But what's really nice is that you have these filters over here on the side where you can filter these counts based off of like specific routes. Like if I want to see how many times have I actually browsed to just the counter page, you can see I've gone there once. But if I instead filter by the home page, you can see that I've gone there twice. You can filter by the routes, and you can also filter by the specific routable component type, like the counter component or the home component, the components that actually have the app page directive at the top that associate a route with that component. All right, so pretty straightforward. This is just a way to get some very simple data on, how much are people visiting the various pages in your app. So sort of basic page view counts for your Blazor applications. All right, so that's the first one. Let me just check to see if there's any questions.
Yeah, so the question that we have is whether this is a server-only feature or it's also for Blazor WebAssembly. And there are things that are server-only, like the number of circuits and things like that I don't know if you've shown. But the majority of things are for both server and WebAssembly.
Yeah, the metrics and experience that I'm going to be showing you today, and the tracing also, are very server specific. In WebAssembly, some of the metrics technically apply to WebAssembly. The issue that we do have, though, is that in order to get the telemetry out of the WebAssembly process is still something that we're working on. Like you basically need to, there's nothing in Aspire today that will like collect the telemetry data, for example, from the browser process and show it in the dashboard. There is like infrastructure in Aspire where they surface the open telemetry protocol, like HTTP endpoints, where you could from the browser push telemetry data to those endpoints. With a Blazor WebAssembly app, there's some complexities there because the .NET libraries that you would normally use to do that, I believe require like a multi-threaded environment, so they don't really work in a single-threaded Blazor WebAssembly environment that we have today. So there's some issues there. So for WebAssembly, most of the stuff that I'm showing you here is not really relevant. Now, if you've attended some of our earlier stand-ups, you have probably seen us demo some of the new Blazor WebAssembly diagnostic tools that we are adding in .NET 10. These are tools that allow you to collect like CPU samples, memory dumps, and some low-level runtime counters from your Blazor WebAssembly apps by like invoking a JavaScript function from the browser and then collecting a net trace file that you can then load into Visual Studio and so forth. So those are tools that we are making available in .NET 10, but it's kind of separate from the features I'm showing today. The features I'm showing today are pretty server specific.
Yeah, I would also add that pushing telemetry from like the browser, that is an environment that you don't control, into the server is way more problematic than pushing telemetry from the server, because you need to have security you need to take security into account and things like that.
Yep. Okay, let's take a look at some more metrics. So the next one I want to show is this event handler metric. So let's take a look at that. So this is basically, this is a histogram based metric where it's going to measure the duration of UI events. Okay, so if I go like to the home page and go back to counter and then click on counter a few times, I should see some events start to show up, and I do. And this is basically like measuring how long it took to call the on-click event handler and invoke our increment count method. And over here on the right, you can see in the filters, you can filter by the specific attribute, the specific event type that got triggered, or the specific event handler that ran, or the component type as well. Now this my increment count method on my counter component obviously doesn't take very long. All it's doing is incrementing an integer. Let's see if we can make that a little bit more interesting. Let me go to my counter page, and let's get Copilot to help me out here. Open the chat window, and let's do, I want to do, okay, let's do, yeah, down here, right, sure, agent mode. So add another button to my counter component that has a 1 second delay before incrementing. Yeah, okay, go ahead and do that, and get a Copilot agent mode to write that code for me. If you're on Visual Studio Preview, you do now have access to GitHub Copilot agent mode. You do need to turn it on. So if we go like looking in the Visual Studio features, or like agent mode, this enable agent mode in the chat pane option. Oop, no, don't want to do that. Well, anyway, you can search for the feature and turn on agent mode in your app, and that will help you do that. Okay, so this is offering to add a button with a delayed increment count. That looks good. Yep, and let's keep all of that. Okay, cool. So we should be able to hot reload that in, I think. And then if we go back to our app, we now have a delayed increment count button. And let's see, does it work? If I click, yeah. So it's about a second, and then it shows up. So I click, and then increments, and click, and then it increments. So now if I go look at the metrics here, and I think I have to like browse away and browse back, we should now see, yeah, we see events for that delayed increment count method that are taking a second. Okay, and I think you might wonder like these P50, P90, P99 graphs. I believe the reason why they spike up is I think they're bucketed, like it's a histogram, right? So like depending on which bucket they sit in, that's where they kind of shoot up to. So they don't reflect exactly the timing of the button click. Like the button click here was just slightly over a second, and I guess there's a 2.5 second bucket is my guess about why that's showing that as a P50, the P50 histogram. Okay. So yeah, that's event handling. So you can get a feel for like which of your event handlers are taking a long time, maybe a little slow, and drill down into which components and which event handlers are maybe causing some issues. All right. Good. All right, just checking the questions. Next, I'm going to jump actually down to these Blazor server circuit metrics. So here we should be able to see like how many active and how many connected circuits we have in our application. Let me make sure. And I think we do have a sort of a known issue with the connected issues where it kind of gets pegged to 0. Looks like I just probably hit that bug. Maybe I'll restart just to make sure we can see that properly.
Well, it was nice to see you.
No, I'm not doing the restart the browser. I'm just gonna restart the app. This should be fine. I still see you guys. You can see me, but I want to sort of show the connected list as well because I think that's pretty important. So with Blazor server apps, there's state that's held in memory for each user effectively of your app, and we call that state the circuit. And it's a stateful programming model. So if the user becomes disconnected, that circuit actually, that state can stick around. Like Blazor will actually kind of wait to see, well, maybe the user just lost their network connection or temporarily went away. Maybe they'll come back. And so we'll hold on to that circuit for a little while to see if they reconnect. That's when you get that like reconnection UI that maybe some of you have seen in your Blazor apps. So it's useful to know in your Blazor apps, like how many circuits do I have? Like how many users have at least connected to my app at some point, and then how many of those are actually still in the connected state. How many are disconnected and how many have an actual active network connection with them. So if I bring up the app and let's go to the counter. Okay, so we should have a circuit now. This is the counter page is the only page in this default Blazor web app that is using interactive rendering. So if we go and look at our circuits, we should see we have an active circuit and it should be connected, and it is. Okay, and so if I like now duplicate this tab, effectively get another user and create another circuit on the server, we should see that pops up. Okay, so we have 2 active circuits and 2 of them are connected. Now, the thing that you then would love to be able to see is if I could close one of these browser tabs, that basically kills the connection for that circuit, but it should stick around a little bit, right?
Dan, there is a question that is like, what is a circuit? And I want to answer that so that like people know about it.
I tried to speak to it before, but go ahead and
yeah. So a circuit is a session of a Blazor user or in a Blazor app. You can equate a circuit with a tab, essentially with an open tab. So the connection for the signal R might go down and might come back, but the circuit stays the same as long as you're on the same tab. If you open a new tab, you get a new circuit, and so on.
So all the like the component instances and their in-memory state is associated with that circuit. It's kind of all managed together as the state associated with that particular user. So every user that comes to your Blazor server app, you get a new circuit. And like Javier says, they can survive across connections. All right, so there we did see a decline in connected circuits. We do have an issue. I think this should actually go down to 1, right, Javier? This shouldn't go down to 0.
Yeah, I think so.
This build is a problem. We're still in preview. We'll get that addressed. But the idea here is that you should be able to now see how many circuits are actually active in your app, how many are in the connected state, which is obviously important as you scale out your Blazor app, your Blazor server-based applications, and think about how many concurrent users do you need to be able to handle with your server resources. When we closed one of the circuits, we then also get data on our circuit lifetime duration. Like you can see, I guess this was a 13-second circuit lifetime, so you get duration information on your circuits as well. All right, so that's pretty useful. Get metrics on basically how many users are active or have used your Blazor server app at a given period of time. All right. Just checking to see if there's any other.
No, go ahead. I'll let you know if there are questions.
All right, cool. So the last set of metrics I want to talk about are these lower level ones, which is render diff.
There is a question now, which is, can you show the table graph?
Can you show the table graph? Yeah. Okay, let's look at, for example, like for active circuits, if we show table, then you can see this is the count going up and down, and as the counter increments, decrements in this case, how that occurs. Cool. Great question. Yeah, Spire is super fun. Like it's actually pretty rich user interface for monitoring your app during development. And we actually use this same UI in Azure Container Apps in the Azure services to provide a diagnostic dashboard for apps that are deployed in production too. All right, cool. So let's talk about render diffs. So render diffs it's kind of like a measure of how long did it take for the components to render, and then to calculate the diff and get that diff applied to the application. Like how long did the rendering cycle of your components take? And you can see here that it doesn't take particularly long for my counter components. It's not doing very much in its rendering. But this would be useful if you have a much more elaborate UI. Like let's say you built a data grid control that has thousands of rows and tens of thousands of cells inside the data grid, and you're trying to see how well is that component behaving in terms of its rendering characteristics. Is it doing a lot of work to render all those cells, or is it doing it more efficiently? So this is a way to sort of get a feel for the rendering performance of your Blazor app. There is a couple of filter parameters on this metric as well, and this is a bit of a low-level concept, but this is giving you sort of a sense of the size of the diff. Now, what do I mean by the diff? Like when the way Blazor works is it's a diffing algorithm-based UI framework. Your components will render their updates, something happens, like you click a button or you trigger some sort of component render so that it says, I want to render some new UI. That UI rendering doesn't actually go directly to the DOM, and it goes to an in-memory representation of the DOM. And then Blazor keeps track of what's already in the DOM and does a diff. It figures out like, well, what changed? And then Blazor handles updating the DOM with just those changes. And so that diff that Blazor calculated could be small. Like in case of my counter, the only thing that's really changing, right, is the count. So it should be tiny. If you're doing a lot more, like rendering a giant data grid, then it might be very large. And so this kind of gives you a feel for how big is the render diff. Now these numbers, what's their units and what is that? What does 50 really mean here is a bit abstract. I think these are even sort of batched sets of render diff instructions, I think is when I looked at this. Is that right, Javier? Do you know the details?
Yeah. I know. So this is essentially the size of the tree, of the virtual tree of the component. And this essentially allows you to see if there is a component that is taking a long time because it's doing a lot of rendering. So imagine that like you go to the database and you like list the entire database in a for loop, that type of thing. The component is just gonna like go and put 1 million nodes, and that's gonna show up in the metrics saying, hey, you have one component that is taking 1 million nodes. So it's telling you that like, hey, this component is slow, is because it's producing a lot of data.
And so nodes in this sense is like individual instructions to update the DOM, like add a
like for example 1 million divs.
Yeah. So kind of a general size metric that, figure that you're getting here with the diff length. So this will give you data on the diff, but also on the actual rendering time, right? Like I think I tried out like we could do this where you if you added like some really long operation, like if I went into my counter component and did something silly, like added a task.delay right here.
You're gonna add task.delay there. Rendering is synchronous. You need to do well. Why do I challenge you? Yes, you can do that, Dan. You can do that.
Yeah. So if I did like this, where I just basically say like waste a bunch of CPU cycles, then I think we should see the rendering time of our component then shoot up. Like if I start, now when I try to click on things, it takes a long time for the counter to update because we're blocking the rendering basically, which you should not do. Don't do this. This is just to prove a point. And then the render times should shoot up. Like if we look in the table. We should. How long did I put in it for? Like a second. Yeah. So now and these are bucketed. So now they're in the 2.5. If I look like at exemplars, now we're seeing 1 second examples of render times. Okay. So that's kind of what that one is giving you a feel for. Let me remove that line of code so I don't forget that I have a task.wait in my app. The other one, the update parameters, is measuring how long does it take for the component to initialize and then set the parameters on the component. So this will cover component lifecycle events like uninitialized async or uninitialized, and also on parameter set async. And I believe it's basically like the set parameters method, which is sort of the lower level piece of code in your Blazor component that populates the parameters into your component. So all that initialization logic and taking parameter data in and doing stuff with it, business logic, is what this metric will give you a feel for. So if you have a component that's doing some really long database queries or something, and it's like, on parameter set async method, then you would see that here. And I believe there's a filter on the type of the component. Okay. So just to show that, like if I go back to my component and let's do like override on initialized async, and then we return like a task.delay here, like that. And we'll start. You guys still there? You guys still there? Yes.
Yes.
Okay,
yes.
I'm all nervous now. Like, what's gonna happen?
How long did it took you to figure out that you were not presenting?
I got through like the whole navigation metric. And
I figured.
And then I went to go look for questions in the StreamYard, and I was like, wait, where did StreamYard go? It disappeared.
Yeah, because you were taking quite long.
My bad. Okay, so we've restarted the app now, and so if we
we have an interesting question, which is what happens if we're not using Aspire, and how do we visualize these metrics and so on? And the good thing I think is that all this is using OpenTelemetry.
that's right.
So you can use whatever OpenTelemetry viewer you want, and it will work essentially.
Yeah, if you wanted to like pump this into Grafana, for example, I think is a popular tool for doing this type of things. That should work perfectly fine. Any tool that accepts OpenTelemetry based data, you can export that data from your .NET processes and feed it into that tool. So here we can see now we're getting a render, an update parameters count on our counter component that took like over a second, which is expected because we added that delay. Okay, so that's metrics. Those are basically, you could think of them as like gauges, histograms, counts of things that are happening in your app. All right, let me remove this delay.
Is the bird's eye view essentially.
So next I thought let's look at traces. Traces is a little different. Traces is like, I want to kind of map through what is the sequence of activities of things that are happening when like a request comes to my app or a UI event occurs. Like, you click the button and that triggers an HTTP request, which hits some API endpoint, which does a database query, and you want to, track all those related activities and see how long they're taking. Did they succeed? Did they fail? Those types of things. That's distributed tracing. And with Blazor, particularly Blazor server, distributed tracing has been a bit problematic because Blazor server is this connected model. Before we were talking about circuits, associated with that circuit is also usually a long-standing connection, like a WebSocket connection. And so when you looked at the activity tracing for a Blazor server app, you would see this giant long request for that WebSocket that's never ended, and it was very difficult to then most tools to be able to look at that and look at all its child activities and reason about what was going on. In a more traditional style web app where you do request, reply, and those are usually reasonably short-lived requests, you would see more like a list of requests and their corresponding activities underneath them, which is much easier to parse. So we've been doing some work in Blazor to add activities that are Blazor specific, so you can track things that are happening in Blazor in a much more reasonable way with available tools like the Aspire dashboard. All right, now to enable the new tracing support, we do need to add a new trace source. So we're going to go back to that extensions.cs file. And instead of looking at the metrics section, which we looked at before, right, we're going to now look at this with tracing section. And we're going to add a new source down here. And the one we want to add, of course, is for Microsoft aspnetcore components, which is the one for Blazor. So let's add that. Okay, and then let's get this running, and that should enable the new Blazor tracing support. While I do that, let me see if there's any new questions. So
we're good.
Someone commented here something along the lines of what we were saying earlier, that it's all open telemetry, so you can use Prometheus and a Docker container. There's lots of open telemetry based solutions that you can use to collect this data besides just using the .NET Aspire dashboard. All right, so where are we running at? That's the previous run. Did it come up? All right, let's close all these previous tabs. Not
Careful with the tab closing.
No one's ever going to let me forget that I
don't have additional topics to talk about.
That's right. Okay, so now instead of going to the metrics tab, we're going to go to the traces tab. So we just, as you can see, we just browsed to the app and did a normal, GET request, and it's pulling down all of the like static web assets that are associated with this app. That's why we see, requests for blazor.web.js. You can see all the fingerprints in there so that they can be aggressively cached. So that's all nice. Let's now go also to the counter and start a circuit. Click the button and trigger some UI events and see what we see now. Now, the first thing you might notice is that the top level of activities that we're seeing in this traces view are, these are like a lot of these are the Blazor server hub. Like under the covers, Blazor is actually using SignalR, which has this notion of a hub and hub methods that you can call. And that's what Blazor uses to handle all of the interactions with the browser when you're doing interactive server rendering. So we see things in here like, Microsoft aspnetcore component server, end invoke JavaScript from .NET, like it's calling into JavaScript code on the browser. These are kind of like implementation details for most people as end users. It's probably useful for Javier. Like Javier sees this stuff as like, yeah, I know what that is. I deal with the Blazor hub all the time. For you guys, probably not as interesting. This is an area we're still discussing. Like, can we improve this? Can we kind of hide some of these SignalR details that maybe aren't as relevant? But we can do some things. Like up here, we see the start circuit hub method being called. That's where we're actually setting up that initial Blazor circuit. And here, then below it, we see this span where we're actually creating an activity for that circuit. Now it's kind of interesting because this activity it's not long. Like you'd see, it's tiny. Like right, it's only like 10.8 microseconds or something. It's not a long span. So this is not tracking the full lifetime of the circuit. This is more like a logical activity that we're then going to use to associate all the other things that are happening with that circuit. We think that's kind of nice because it avoids having these really long spans for like, a circuit could last hours as the user is using the app, which can really kind of flood your tooling and make it hard to use. So instead, we have these sort of logical circuit activities that we're using. If we click on one of these, we can see that the circuit is now linked to all sorts of interesting things. Like every time I clicked on the increment count button, you can see that it's being linked to the corresponding event that occurred for that button click. So we get links from UI events back to that circuit. So we can filter on all the UI events that are associated with that circuit, for example. That's one thing. We can also, let me go back to the top level traces. We can see things like page navigations and the like. So if we scroll up here to what's a good let's see, is it this one? I don't know. I almost kind of wish so kind of funny thing with this app is that it's only got one routable component. So I don't think we even actually necessarily see that if you had multiple components that were routable, you would see like an on location changed activity that would also show up in here. So you can track through component.
Is the app set up on per page interactivity?
Yeah.
Yeah, that's why you don't see the events.
I can change. Let me change that real quick. So let me close this down, and then let's fiddle with our app to make the whole app interactive. So if I go now into app.razor, and here are my routes, I'm going to say I would like the render mode for this entire app to be interactive server. And then we'll do that also on the head outlet. Make that interactive too, and then I don't technically need it anymore on my counter because I am handling it globally. Okay, so now the router itself is even interactive, and so we should be able to see like activities that are associated with page navigations, which is super convenient because before that was really hard to see in tracing with Blazor server apps. Okay, so now if we get this going, and then let's do some navigation to home, counter, and then weather, right? And let's look at the traces. Let's look through here. Yeah, okay, so now you see like this on location changed. So there's the browse to the weather page. If I go look up a little bit more, we should be able to see the other ones as well. So like on location change here, this is probably the one to home. And then there should be one for the counter as well. Now it'd be nice if these were like, this is what we were talking about this earlier, right, Javier? Like it'd be nice if these were kind of top level so I could just see the activity. Yeah. But yeah, there's the counter one too. All right, so you now have these Blazor specific tracing activities that we're adding for navigations, for UI events. Again, if we like click on these things, we can see that they're conveniently linked to a whole bunch of metadata, like what the circuit ID is. And so you can correlate all these activities together, correlate the events to the circuit, and so on. So that's the new tracing support. Where is the circuit? Yeah, here's the circuit ID, right? So you can get the circuit ID from each of these activities and link that back. Cool. All right. Any other questions about that? I don't see any. Okay. So these bits, like I said, are not available yet for you to try out. They will be available shortly in about a week. We'd love for you to give them a try. If you are deploying production Blazor apps and have always wished that you had deeper insights into what's going on with your production app, try upgrading to .NET 10 and giving these new metrics a try and see if they give you what you're looking for. If there's stuff that's still missing that you wish you had deeper insights into some other dimension of your app, let us know. If you feel like the behavior of some of these metrics isn't quite right or quite what you would expect, let us know that as well. The idea is that you get much better observability and diagnostics into your apps, whether you're running them in production or doing them in development, like we just did here with .NET Aspire. Again, I think we talked about WebAssembly earlier. I did want to touch on that one more time. This is a server rendering centric set of metrics and tracing support. WebAssembly is more complicated because getting the data out of the browser involves some additional infrastructure. That is something that we plan to look at, but not for .NET 10. It's a future problem that we'll try to address. In the meantime, you do have the new .NET 10 diagnostic tools for getting CPU samples, memory dumps, and some low-level runtime counters using the new JavaScript APIs for extracting that information. Good.
Awesome.
Great. And here is, let's see, someone says, Blazor is very well set up for traces like this. I always hesitate to add open telemetry to the client on SPA-based apps because of the extra client traffic. Okay, that's interesting. Yeah, I mean, there's a balance there, right, of like having I think with telemetry in general, right, like how much data you want to get out of the app versus the overhead that sometimes having that telemetry enabled can impose, and that can be particularly sensitive with like a Blazor WebAssembly app. Like you have to enable, runtime features to even get the telemetry infrastructure to work, which can make this app a little bigger, and how much data, how noisy the data is, like how much data you're pumping out can matter. That's why you have a lot of these fine-grained controls over like which metrics do you want to enable and which tracing sources do you want to use. So you just only get the data that you actually care about. There are some examples of pushing telemetry data out of JavaScript-based apps to the Aspire dashboard. The Aspire dashboard does support the OpenTelemetry HTTP endpoints. And there is, I think, in the Aspire Playground, in the Aspire repo, there's a sample app that shows how you can integrate with those endpoints. At some point, we'd love to have a similar story for Blazor WebAssembly, but we're not quite there yet. Ooh, and I think that is it. All right. So thank everyone for showing up today. Next week, mark your calendars because we're going to have our normal Blazor community stand up next week. And Javier is actually going to be our star presenter. Javier, what are you going to be talking about next week?
So we are going to be showing the persistent component state work that we have been doing that allows you to save the state of a circuit when it's not being used or when the connection goes away for some reason, and then bringing the app back to life.
Yes. So we were just talking about all those circuits, right? And so now having a way to actually take that state in the circuit and save it so you can reload it later. So yeah, super cool stuff. I've seen some early demos of what Javier is going to show. It's pretty exciting. We think you'll like it. So yeah, tune in next week, next Tuesday, 10 a.m. Pacific time, and we'll just tell you all about it. Until then, happy Blazoring, happy coding, and we'll see you next time. Bye, everyone.
Thank you. Bye-bye.